Alright, in today's video we are going to be working on evaluating algebraic expressions. To evaluate an algebraic expression like the one you see here, a plus 3b divided by 6, you're going to substitute the values of each of the variables into the expression, and then you're going to use order of operations. So in this problem we see that a is equal to -5, that's shown right here, and we know that b is equal to 10, which is shown right here. So what we will do is we'll rewrite the expression, but in place of a, we'll put our -5, and in place of the b, we'll put 10. Therefore, this expression becomes -5 plus 3b's means 3 times b, so 3 times 10 divided by 6. From here, what you're going to do is you have to follow order of operations. So remember, we always start with parentheses. In this case, the parentheses are acting as multiplication, so we don't have parentheses as an operation. Moving on to exponents, we don't have any exponents in this problem either, so we'll move on to our multiplication or our division. In this problem, we have 3 times 10, or 3 being multiplied by 10, which is 30. So the -5 is not impacted. It becomes -5 plus 30 divided by 6. Multiplication and division exist in the same step, and because the multiplication came before the division, left to right, we did it first. Now we need to go ahead and take care of the division in this problem as well. So the next thing we're going to do is do 30 divided by 6. The -5 again is not impacted, so we'll have -5. 30 divided by 6 is 5, and it is a positive, so we'll write plus 5. The last operation that we have to do in this problem is -5 plus 5, and -5 plus 5 gives us a 0 pair, or rather 5 0 pairs, so we're left with 0. Therefore, when we evaluate this algebraic expression with a being equal to -5, b being equal to 10, we get a value of 0. Alright, for the second example that you see on the screen, it looks a little bit more complicated, but we're really going to follow the same process. So for this one, we have 2x squared minus 3y, and that is all being divided by z, and we're going to evaluate it for x is equal to 3, y is equal to -4, and z is equal to 2. So just like in the last example, the first thing we're going to do is we're going to substitute each of those values in for each of the variables. So when we rewrite this expression, when we evaluate it, we'll still have 2, but instead of x, we'll substitute in the value 3, so it becomes 2 times 3 squared minus 3, but then instead of y, we're going to use -4, so it's -3 times -4, and then it's all going to be over z, which in this case is 2. We're going to once again go ahead and follow order of operations, starting with parentheses. Once again, we don't have any parentheses that are holding on operation, so we're going to move on to exponents. We do have 3 squared, which means to do 3 times 3, or that becomes 9. So when I evaluate the 3 squared, it becomes 9, so my expression is 2 multiplied by 9 minus 3 multiplied by -4, all divided by 2. Our next operation is going to be multiplication division again. We have both of those. Because there is more than one operation in the numerator of this, we're going to treat that as grouping, and we're going to go ahead and do the multiplication. We can do the 2 multiplied by the 9 and then the -3 multiplied by the -4, or we can do both of those in the same step because they're really not impacting each other. So when I do that, I'm going to take the 2 multiplied by the 9, that's going to give me the 18. Then I'm going to take the -3 times the -4, because those signs carry with those numbers. That becomes a positive 12. And that is still all going to be divided by the 2 because we haven't dealt with that yet. Like I said, this becomes a grouping operation with that fraction bar. So the next thing we're going to do is the 18, and we're going to add it to the 12, because remember that 12 became positive when we multiplied the 2 negatives. So we have the 18 added to the 12 becomes 30, still over the 2. And then the last thing we're going to do is we're going to do 30 divided by 2. And so our final value of this expression is going to be 15.